Hey everyone, Tech Guru here. The tech world is undergoing a massive shift, moving away from the traditional x86 processors found in most computers for decades to ARM-based systems like the latest Apple M4 and Windows ARM devices like the Surface Laptop 7. Why is this shift happening and what does it mean for users in 2024? Today, we're going to explore the main reasons for this transition, the challenges, and how these new ARM processors compare. We're diving into the fascinating world of ARM processors and their growing impact on the computing landscape. You've probably heard of ARM, especially with Apple's switch to their own ARM-based M-series chips in Macs. But ARM's reach extends far beyond laptops. It's powering smartphones, tablets, servers, and even some Chromebooks. So why is ARM gaining so much traction? Simply put, ARM chips are designed for efficiency. They excel in mobile devices where battery life is crucial, but their performance has been steadily increasing, making them viable contenders for more demanding tasks. This shift from the traditional x86 architecture, commonly found in PCs, marks an exciting new era in computing. We're going to explore the reasons behind this transition, delve into the technical differences between ARM and x86, and examine the potential benefits and challenges that lie ahead. Get ready for an in-depth look at the future of computing. To understand the ARM revolution, we need to talk about RISC and CISC. These acronyms stand for Reduced Instruction Set Computing and Complex Instruction Set Computing, respectively. They represent two fundamental approaches to processor design. x86 processors, like those from Intel and AMD, are based on the CISC architecture. They're like Swiss Army knives, capable of handling a wide array of complex instructions directly. This complexity can lead to larger processor sizes and higher power consumption. ARM processors, on the other hand, embrace the RISC philosophy. They focus on a smaller set of simpler instructions, which allows for more compact designs and greater power efficiency. Think of it as having a dedicated tool for each task, resulting in a more streamlined and energy-efficient process. This difference in design philosophy is at the heart of ARM's advantages in mobile devices and their growing potential in other areas. With Apple's M-series now at M4 and Microsoft's renewed focus on ARM with the Surface Laptop 7, we're seeing this shift take off. Apple and Microsoft are investing heavily in ARM technology to create laptops that run cooler, last longer on a charge, and offer better AI and machine learning performance compared to traditional x86 systems. But what does this mean for software? But it also presents challenges, particularly when it comes to software compatibility, which we'll explore in a bit. One of the most significant advantages of ARM processors is their power efficiency. As mentioned earlier, the RISC architecture allows ARM chips to be incredibly power-sipping. This has been a game changer for mobile devices like smartphones and tablets. Think about it, you want your phone to last all day on a single charge, right? ARM makes that possible. The reduced power consumption means less battery drain, giving you more time to browse, game, and stay connected. But it's not just about battery life. Power efficiency also translates into less heat generation. This is crucial for mobile devices, where excessive heat can impact performance and even damage components. ARM's efficiency keeps things cool and running smoothly. This focus on power efficiency is also becoming increasingly important in other areas of computing, such as data centers and servers, where energy consumption is a major concern. ARM's ability to deliver performance with minimal power draw is a compelling proposition. Apple's decision to transition its Mac lineup from Intel x86 processors to its own ARM-based M-series chips was a bold move. It marked a significant shift in the personal computing landscape, signaling a growing confidence in ARM's capabilities beyond mobile devices. The transition began in 2020 with the release of the M1 chip, which powered the MacBook Air, MacBook Pro 13-inch, and Mac Mini. The performance gains were immediately apparent, especially in terms of power efficiency and graphics performance. Since then, Apple has continued to iterate on its M-series chips, releasing the M1 Pro, M1 Max, M2, and most recently, the M4, each generation pushing the boundaries of performance and efficiency. The transition has been widely praised for its positive impact on battery life, performance, and overall user experience. Apple's successful transition has undoubtedly accelerated the adoption of ARM in the PC market, demonstrating that ARM processors are capable of handling demanding workloads previously considered the exclusive domain of x86. Section 5. Microsoft's foray into ARM, a tale of two platforms. While Apple has fully embraced ARM for its Mac lineup, Microsoft's approach has been more cautious. They've dipped their toes into the ARM waters with devices like the Surface Pro X, but they haven't fully committed to a complete transition like Apple. Microsoft's strategy with ARM has been two-pronged. On the one hand, they've released Windows on ARM, a version of their operating system specifically designed to run on ARM processors. This has allowed them to offer lightweight and power-efficient devices like the Surface Pro X. On the other hand, Microsoft continues to heavily invest in their x86-based Windows operating system, which remains their primary focus. This dual-platform approach reflects the challenges and opportunities presented by ARM. While ARM holds promise for the future, the existing x86 ecosystem is vast and deeply entrenched. Microsoft is carefully navigating this transition, trying to leverage the benefits of ARM while ensuring compatibility with their existing user base. Section 6. The Software Conundrum, Compatibility Challenges and Solutions. One of the biggest challenges with moving to ARM is software compatibility. Many applications, especially older or highly specialized software, were built for x86 architecture. This means they don't run natively on ARM chips, which can create some issues for users. The vast majority of software applications are written for the x86 architecture. This means that running these applications on ARM devices requires emulation or recompilation. Apple tackled this with Rosetta 2, a high-performing emulator that allows x86 software to run on M-series Macs with minimal slowdown. Microsoft, however, is still refining its own x86 emulation for Windows ARM. While compatibility on Windows ARM has improved significantly, it may still have issues with specific legacy applications, particularly those that rely on high-performance graphics or low-level system access. Emulation involves translating x86 instructions into ARM instructions on the fly. While this allows x86 applications to run on ARM devices, it can result in a performance penalty. The efficiency of emulation has improved significantly in recent years, but it's still not a perfect solution. Recompilation, on the other hand, involves modifying the source code of an application to run natively on ARM. This results in optimal performance, but it requires developers to put in the extra effort to support ARM. Many software developers are now releasing ARM-native versions of their applications, especially for mobile devices. However, there's still a long way to go before the ARM software ecosystem reaches parity with x86. Performance Showdown. Apple M4 versus Qualcomm Snapdragon X Elite. Now let's talk about performance. Apple and Qualcomm are major players in the ARM space. Both push ARM performance boundaries. The Apple M4 is a powerful, efficient processor. Qualcomm's Snapdragon X Elite is another powerhouse, designed for high-end devices with 5G connectivity. Both showcase ARM's impressive performance capabilities. Now let's get into the performance and efficiency that ARM offers, specifically with the latest chips like Apple's M4 and Qualcomm's Snapdragon X Elite in the Surface Laptop 7. The M4 is built on a 3 nanometers process, packing 10 CPU cores and a GPU that can handle 4K video editing and even real-time ray tracing. This power is paired with incredible efficiency, giving the MacBook Air with M4 up to 20 hours of battery life in some scenarios. The Surface Laptop 7 with Snapdragon X Elite is also built for efficiency, with up to 23 hours of battery life under optimal conditions. The Snapdragon X Elite has 12 custom Orion cores, designed for high-performance tasks, and operates at speeds of up to 4.3 GHz. Both devices support all-day use, but the M4 has a slight edge in handling graphic-intensive tasks thanks to its advanced GPU. Section 8. AI at the edge. ARM's growing prowess in artificial intelligence. ARM processors are crucial in the AI revolution, transforming the tech landscape. A Surface Laptop 7 with Snapdragon X Elite is also built for efficiency, with up to 23 hours of battery life under optimal conditions. The Snapdragon X Elite has 12 custom Orion cores designed for high-performance tasks and operates at speeds of up to 4.3 GHz. Both devices support all-day use, but the M4 has a slight edge in handling graphic-intensive tasks thanks to its advanced GPU. Their energy efficiency is ideal for edge AI, processing data locally. Think smartphones with facial recognition, voice assistance, and real-time translation. These features run on ARM processors within the device. This ensures faster processing, reduced latency, and enhanced privacy. Apple and Qualcomm invest heavily in AI for their ARM processors. These AI capabilities make tasks like voice recognition, video analysis, and augmented reality run more smoothly on ARM devices. ARM's architecture, combined with these NPUs, allows for advanced machine learning applications without compromising power efficiency, a huge step forward compared to x86 systems. ARM processors are at the forefront of the AI revolution, enabling intelligent devices. Section 9. Graphics and Gaming. Bridging the gap with x86. While ARM has made significant strides in overall performance, graphics and gaming have traditionally been areas where x86 processors held an edge. However, ARM is rapidly catching up thanks to advancements in ARM-based GPUs and the growing support from game developers. Apple's M-series chips, with their integrated GPUs, have demonstrated impressive graphics performance, rivaling dedicated graphics cards in some cases. They've shown that ARM-based systems are capable of delivering smooth and immersive gaming experiences. Qualcomm's Adreno GPUs, found in their Snapdragon processors, are also gaining traction in the mobile gaming market. These GPUs are designed to handle the demands of graphically intensive games, providing a console-like experience on smartphones and tablets. As ARM technology continues to evolve, we can expect further improvements in graphics and gaming performance. The growing adoption of ARM by game developers and the increasing availability of ARM-optimized games will further bridge the gap with x86, making ARM a viable platform for even the most demanding gamers. In summary, ARM processors like Apple's M4 and the Snapdragon X Elite in the Surface Laptop 7 are leading the way toward a new standard of computing. They offer incredible battery life, efficiency, and AI capabilities. However, compatibility with older x86 software may still present challenges, especially on Windows ARM devices. But as more developers optimize for ARM, the shift is likely to become smoother for users. So, are you ready for ARM or sticking with x86? Let us know in the comments. So buckle up and get ready for a wild ride. Thanks for watching. Don't forget to like, subscribe, and share your thoughts. Would you make the switch to ARM, or are you sticking with x86? See you in the next video.